All right, we should be live. Can I help you, Missy? What a silly cat. Oh, let me send out the announcement. Good morning. My cat is now stuck in the office with me because she closed the door herself. She is not a smart cat, and now she's struggling to get out. I'll let her out in a minute. All right, let me let her out really quick. She doesn't want to be in here. Hey, Hermit. Welcome to the channel. I'm glad you found it. And now she wants to get in. Cats are... You can't live with them. You can't have your face eaten after you die without them. Yeah, I mean, look, cats are just like this sometimes. Right. There's a question, how does mass transmit to the escaping virtual particles in the event of Hawking radiation? So we don't really have a good understanding of what happens inside the black hole, like within the event horizon. But what we do know is that we have negative energy, that we have particles with negative energy that enter the black hole. And so just by basically simple energy conservation, the mass of the black hole has to go down. Now, how it works that the mass goes from near the event horizon and pulls mass and like decrease the mass at the center, that's not clear. But this is what happens, at least in the virtual particle picture. I don't think it's a great picture though. I think a better picture is rather that you have fields inside that can tunnel out quantumly. Yeah, so can you explain how the sun is constantly consuming at a crazy rate but still sustaining? The trick is that the sun is so much bigger than you think it is. So we can just look up how much mass does the sun lose per second. So the sun loses 4.3 billion kilograms of mass every second, something like that. It converts mass into energy via nuclear fusion, and then it also ejects mass via the solar wind. But the thing is, that's 4 times 10 to the 9th kilograms. The sun weighs 2 times 10 to the 30th kilograms. So that's 21 orders of magnitude difference. So that's why. That's how. It's just insignificant compared to the mass of the sun. I think you should get on Modern Day Debate and own these rising Christians like Andrew Wilson. Don't mean to take off. So I've spoken with Andrew Wilson before. He's not a good faith debater, so it's not really interesting. I've also been on Modern Day Debate before, so... Can you explain more about the dark stars, and do you think that they exist? So dark stars are a type of black hole, or at least it's a hypothesized explanation for what's going on at it, like whether or not it's an explanation for what a black hole actually is. If I understand correctly, these are things that have outward pressure. These are things that have outward pressure basically keeping the black hole event horizon up, and inward pressure from gravity pulling it down, and you get a sort of equilibrium right at the size of the black hole. And we don't really have evidence yet that this is a true thing, but it's something that people are taking seriously. Is mathematics discovered or invented, and does your work lean you one way or the... Oh, I forgot my water bottle. So I think that mathematics is invented, but that's a personal thing. A lot of mathematicians disagree with me. I forgot my water bottle. Sorry about that. Mass create energy or energy create mass? Mass is just is a kind of energy, essentially. Andrew can't open jars and his wife has 3 baby daddies. Just saying. The universe isn't expanding faster, studied by the Korean scientists. What do you think? I already made a video about this. Like, the day it came out, I made a video about it. What do you think of Mach's principle? I think it's a fascinating way to try to think about, and like kind of as a, like a, not a contrapositive, as like a counterfactual, to kind of understand like what motion really is. It's certainly an interesting question. Thank you, Buckaboo. My wife loves me so much that she brought me my water bottle. For the average layperson, what are some decent sources to keep tabs on recent scientific findings? So phys.org is usually pretty good. It has some issues, but phys.org is pretty good. Scientific American is also generally pretty good. I think that they generally write pretty good articles. Angel of Light made an interesting video of you when you had your debate. We had a debate like a year ago. Is he still thinking about it? Man, I must live rent-free in his head. Wait, you're married? Yeah, of course I'm married. How do we measure consciousness? Is there literally any metric? You'd have to ask like a neuroscientist about that. Can you explain tensors? Yeah, so tensors are, you can think of them as geometric objects that, actually, perhaps that's the best way to think of it. Just think of it as like something representing a geometric quantity or a geometric object. Think like an arrow. An arrow has a direction and a length, and it doesn't really matter what coordinates you use to describe it. It has the same direction and it has the same length. But if you change your coordinate system that you use to describe things like position and direction, then the numbers corresponding to the arrow, the way that you represent the arrow mathematically might change, but the underlying object never changes. Is it true that water is blue and glass is green, or were you joking? No, that's true. That's actually true. Can you keep zooming in on subatomic particles like Planck's? If not, why? It's not clear. So it seems like our best theories say that the most fundamental particles are things like electrons, neutrinos, and quarks. There's nothing that you can zoom in to see something smaller inside of those. Those are fundamental as far as we can tell. But maybe that's wrong. Maybe we just haven't seen the experimental data that does say that they're made up of something even smaller. Is your wife also a scientist? She is not. Are the building blocks of everything atoms, strings, fields, something else? What? Well, so I mean, our best models say that it's fields, but maybe there's something deeper that we don't understand yet. Can you please explain the optics, please? I always have trouble on that. So you'd have to be more specific. And please don't spam, by the way. I'll have to mute you if you keep spamming. Okay, I have to mute this guy. Don't make me do it. Wouldn't we kind of expect them to be made of even smaller things, quarks? Not necessarily. No, not necessarily. It doesn't necessarily follow. It could just be that they're fundamental, right? Like that's a possibility. It's a weird possibility, but it's a possibility. Black hole, infinite density and no mass, but if it were infinite, wouldn't there be infinite pull? So black holes, if singularities exist, which it's not clear that they do, then there would be infinite density at the center of a black hole. But that doesn't mean that there's no mass, and infinite density also doesn't mean that there's no pull, or that there's infinite pull. Tim Bimbadil sent $5 to ask, had a super potent gummy last night, but you're still the best Blitz around. I appreciate that, Tim Bimbadil. Does the math allow dense matter like element 115 or above stable to produce anti-gravity effects? No, no, and element 115 isn't stable. Like we've made element 115, it's like horribly unstable. When debating a Flerf, you said there was never no universe, meaning before the Big Bang. What do you mean by that? So what I mean is that I don't think that it makes sense to talk about what there was before the universe. I don't think that there was ever nothing. And if there was never nothing, then there was always something. What's the deal with magic numbers of stable nuclei? This is a really good question. So you know how like with atoms want to have full shells? So you want to have 2 electrons in your first shell and 8 electrons in your second shell, or however it goes, whatever chemists teach you. So you can describe atomic nuclei in much the same way with shells and you know, kind of full shells and empty shells and things like that. It's just both protons have shells and neutrons have shells, and you want to fill them up so that they're the most stable. So it's the same way, very much the same. Now, of course, the actual underlying mechanics is much, much more complicated, but it's a good approximation. Is Planck length smallest thing, or we don't know anything smaller than that? So the Planck length is believed to be kind of like an operationally smallest distance that you can measure, but it's not. It's perhaps not the smallest possible thing. It just might be the smallest possible thing that we can measure. So the debate with Andrew Wilson isn't recorded anywhere, as far as I can tell. Maybe on his channel, but it was a long time ago. With limited amount of mass in the universe, what will happen with the expansion? Who says that the amount of mass in the universe is limited? It's not even clear that there's a finite amount of mass in the universe. Geraint sends $5 to ask, on Unapologetic, you said being struck by lightning makes being struck again more probable, but didn't explain why. I don't know why. I just know that statistically this is true. Once you've been struck by lightning once, apparently, and you can check me on this. Maybe I was lied to by misinformation or whatever. But apparently, once you've been struck by lightning once, you are just more likely to be struck by lightning again. And maybe it's a statistical thing that that there's like some bias, and like the kind of person who's likely to be struck by lightning is also the kind of person who's likely to be struck by lightning again. But yeah, apparently that's just a thing. What's the alternative to the universe existing? I don't think that there is one. That's the point. How do you visualize unlimited density in 3 dimensions? I don't know how to visualize density, period. Like, how do you visualize density, period? Are physicists hyped big crunches back in the menu? I mean, I am, but I don't know about the general consensus. How close are we to understanding the physical phenomena that corresponds to the mathematical models of quantum physics? That's a philosophy question, really. And I'm not sure if it's like a thing that science really touches on. Yeah, like the kind of person who gets struck by lightning is definitely the kind of person who just carries a pitchfork on stormy days. That's true. But you know, yeah, you'd think that if somebody got struck by lightning, they would avoid getting struck by lightning at all costs at some point in the future. So you'd think that it would change their behavior, right? Is there any specific field in physics that you're particularly interested in or specialize in? I do relativity. Relativity and differential geometry are my bread and butter. And things that touch on relativity, like I'll touch on like some cosmology stuff, some quantum gravity stuff. Like those are things that I like. But basically, if you can describe it using geometry of a pseudo-Riemannian manifold, I'm down. Tally Beck sends $10 to mention regarding lightning, probably has to do with places they frequent, like golf courses. Yeah, that's probably exactly it. Thank you for the $10, Tally. There are only 2 infinite things in the universe, and he was okay, fair. What do you think will be the most impactful technological breakthrough in the next 20 years? Oh, I have no idea. Do you have Hans potato nose? What? I have hands. How does the concept of manifolds get applied to real life? Well, the underlying mechanics of relativity is all manifolds. Like, it's just all manifold geometry. And so wherever relativity shows up, you have kind of underlying, you have manifolds popping up. And so like GPS involves general relativity, which in order to make those calculations, you need to do manifold calculations. So yeah, there's just a lot. Also, there's like non-relativistic stuff that involves manifolds. So I just don't know what they are. I know that some quantum computing stuff that involves manifolds and like manifolds of quantum gates and things like this. But yeah, there's just a lot of stuff. Miko Makapo sends £5 to say, as a relaxed empiricist, if Dr. Blitz and or Dr. Brian Cox say something's true, it's true. Well, look, I appreciate that, but take everything that everybody, well, okay. I appreciate that. Just make sure that it sounds reasonable. And if it doesn't sound reasonable, ask questions, right? Do you think the edge of the universe is just how far matter has gotten? I don't think there is an edge of the universe. How do you, as a physicist, feel the evidence of events coming, what does this question say? Evidence of events coming out to the public. I don't know what events you're talking about. Do you mean like the stuff involving the president? Because that's just hilarious. What do you think about the guiding wave theory? What if Planck's constant is the wave? So Planck's constant isn't a wave, it's a constant, but you're talking about pilot wave theory. I don't think that pilot wave theory, by the way, pilot wave theory, for those who don't know, is an interpretation of quantum mechanics, or an alternative theory of quantum mechanics, which says that there is an actual real particle, and the real particle's motion is determined by the wave function, and the wave function is not measurable, but the particle's motion is. Now, I don't think, like, I think that this is kind of, I think that this kind of violates Occam's razor. I think it's probably not true, but, you know, evidence could come out that says otherwise. You stream on something other than TikTok? Yeah, TikTok and YouTube. I'm aiming for a pure maths degree and a master's. Should I aim for a physics degree after? If you want to. You don't have to, but if you want to, if you like it. How does the Higgs boson give mass to matter? So first of all, you have to think of mass and energy as, or mass and energy as interchangeable, basically. You also have to think of mass as an energy that like it's a certain amount of energy that contributes to the equations that describe the path a particle takes through space-time. And so what you find is that the interaction between a particle and the Higgs field, it's not the Higgs boson, which is kind of the particle, the Higgs field, that interaction affects the equations that govern the particle, and the way it affects the equations is identical to the way that mass would affect the equations. So that's the mechanism. It's basically it's an extra term that kind of induces a mass-like term in the equation. Now, how you want to think about it physically, often people think about it like the Higgs field is like molasses, and then particles are kind of slowed down as they're traveling through it, and slower things have to have mass. They can't move at the speed of light if they have mass. And if they're not moving at the speed of light, then they have to have mass. So that's one way to think about it intuitively. What is a manifold, Sean asks. So a manifold is a very, very general idea. The kind of manifolds I work with are smooth differentiable manifolds. Well, they don't have to be smooth, but they do have to be differentiable. So a differentiable manifold is just kind of like a generalization of a smooth shape. So, you know, like the shape of a Pringle, it's kind of like this way and then this way. That would be an example of a manifold with a boundary. It has an edge around the edge, and then it has like a shape that's like curved and, you know, smooth and all sorts of things. Spheres are manifolds. So manifolds are they're basically a way of describing, kind of in a general way, different ways that spaces, like two-dimensional spaces, three-dimensional spaces, four-dimensional spaces, whatever, that can be curved in a mathematical way. That's roughly what a manifold is. Now, there's a technical definition. It's something that's locally Euclidean and blah, 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 blah. But, you know, maybe it has an inner product if you want that. But that's the rough idea. Can you explain why some physicists say the universe could be eternal, never had a beginning? What is the basis evidence for that being the case? Well, look, so never had a beginning is... Okay, so eternal and never had a beginning aren't necessarily the same thing. Stephen Hawking thought the universe had a beginning. Okay, let me rephrase. So eternal and never had a beginning are the same thing, but there being a beginning, no, okay. Eternal and not having a first moment are the same thing, but you can think that there was never nothing and still think that there was a first moment of time. This is what Stephen Hawking thought. But roughly the idea is that, look, the physics doesn't say anything about whether or not there was a beginning. And so we, as physicists, we try to understand as far back as we can. And so some physicists will try to come up with models that explain what caused A, and then what caused, or, you know, try to explain that B caused A and C caused B and D caused C and so on. And the model that they come up with is one that goes on forever in the past. And that's like a totally fine thing to do. You can come up with models to try to explain whatever you want. Now, as far as evidence is concerned, there is currently no evidence that supports whether or not the universe had a beginning. It's just not clear whether or not there was a first moment of time. We just don't know. There's no evidence one way or the other. So we come up with models and see which models best fit the data that we do have, and then you can use Occam's razor and so on. And then we can propose new experiments, new observational constraints, and things like that. Is chemistry a big part of physics? No, I wouldn't say so. Is it physically possible for... No, I can't answer that. Hello, is there an equation or a certain way to determine the size of a diode to get a certain output? An output of what? Like, are we talking about a laser diode, an LED? Are we talking about like just a regular semiconductor diode that is unidirectional current flow? Is time physical or an abstraction we use to describe what occurs when action transpires? So Look, this is a question, this is a philosophy question. The trouble is that it's not clear what it means for a thing to be physical. If by physical we mean does it obey laws of physics, then yeah, time is physical. They're like time is one of the things that appears in the laws of physics, and it warps when you're in the presence of strong gravitational fields and all sorts of things. So in that sense, yeah, but if you mean is it like tangible? Well, maybe not. Like that's a little bit harder to say. Have you heard of the lasers used to heat gold past its melting point, but it does not melt? Yes, I have. Can you explain the twin Higgs theories? I haven't looked into them. I've heard of them and I'm mildly familiar with them, but I haven't looked into them, so I'm not going to speak on something I don't know about. Does that mean that if we can manipulate the Higgs field, we could remove mass from matter? Well, I guess in the same way that like if you could manipulate the gravitational force, like the gravitational constant, you can manipulate gravitational force. But like these are things that you can't do, right? You can well, so to be clear, you can manipulate the Higgs field, but that's all you can do is just make Higgs bosons pop out of it. You can't change the underlying features of the Higgs field like its vacuum expectation value. The vacuum expectation value is what the Higgs field does when there's nothing around. And so anything that you do will just not affect what it does when there's nothing. Are you guys easily able to measure the frequency of electrons in subatomic particles? Well, I wouldn't say it's easy, but like, yeah, these are things that can be done. How does dark matter bend light when light is massless? Well, the way that gravity manifests in our universe is by the curvature of spacetime. And so anything traveling through spacetime is going to be affected by that, whether it has mass or not. And light, of course, is moving through spacetime. Like an equation or a certain way to determine the size of a diode to get a certain electrical output? No, I don't think that that's a thing, because it depends on like the materials and all of this. You just have to look at the data sheets. How does frame dragging in a Kerr black hole affect the trajectory and observed frequency of a photon emitted tangentially just outside the event horizon? That's a calculation that you would have to do. It will affect it though, and it depends on what direction it'll be emitted in, right? So if it's emitted in the direction that's going with rotation, it will gain, it will have a higher frequency than you would have expected for a non-rotating black hole. If it's emitted in the opposite direction, it'll have a lower frequency. What's the difference between gravity and mass when you were talking about time dilation? Well, gravity is you can think of it as like the bending of space-time. Mass is what causes the bending of space-time, among other things. Could you define gravitational and electric potential in an intuitive way? Yeah, so roughly you can think of potential energies, any kind of potential energy, as just the energy associated with being at a place but not moving. That's it. So if you are deep in a gravitational potential well, that means that you have very little energy, very little gravitational energy. And so if you want to escape the gravitational potential well, you have to add energy. You can think of as it being a well that you have to climb out of. You have to add energy to escape. Similarly, it's the same way with electric potential. If you are deep in an electric potential well, you have to either, well, if you're deep in an electric potential well, you have to add energy to escape. If you are on an electric potential hill, you can just kind of let go and you'll fall away from it. You into chemistry as well? No, not really. How does one get a PhD in your own experience? Well, first you go to undergrad, then you go to grad school for a PhD, and then you work with your advisor and you do research, and then they give you a PhD. That's roughly it. What would happen if every atom in the universe simultaneously had an additional electron? Well, wouldn't you be surprised that I recently, as 30 minutes ago, uploaded a video answering that exact question? So you should go watch that. Why do we care about the generators of, for example, SO3? Well, so generators are just ways that, okay, so for SO3, you probably don't care about it unless you're trying to like understand the mathematics of like the algebra, or the, in this case, I guess the Lie group. But if you're trying to do physics with, say, a gauge group, and your gauge group is, I don't know, SU3 or SU2 or whatever it might be, those generators are exactly the degrees of freedom in the gauge directions. And because those generators are, because when we're doing quantum field theory, what we do is we kind of promote the gauge generators to particles. Each generator essentially corresponds to a particle, a type of gauge field. And so in SU2, you have 3 generators. And so you will get 3 particles, the W plus, the W minus, and the Z. In SU3, you have 8 generators, if I remember correctly. And so you have 8 different gluons in the adjoint representation. Yeah, like that's what the generators are, at least as far as physics is concerned. From the Mad Cow with $5, we have the question, does acceleration time dilation arise because C limits how fast an object's changing field configuration can internally update structure during motion? No. No, because, so acceleration doesn't really have to do with time dilation. You experience time dilation even when you're not accelerating. It's just that when you are accelerating, you're transitioning from frame to frame, so your time dilation is kind of not symmetric. But the point is the reason why time dilation happens, like even from your own perspective, nothing is happening. From somebody else's perspective, it's kind of correct in a sort of roundabout way. From somebody else's perspective, everything moves slower because light is moving at the same speed. So it's not quite that like you experience time dilation. You never experience your own time dilation, right? But somebody else will see light moving at a fixed speed, and so that kind of forces your time to move slower. But it's not just like you feel like time is moving slower even though it's not, because this is symmetric. If you're moving fast relative to somebody, they will see your time as moving slow and you will see their time as moving slow. So it's not just like oh, it appears that way, but it isn't actually that way. It's actually that way. And Master Forte sends $2. Thank you for the donation, Master Forte. I appreciate you. Do you think the Higgs field could be polarized? And if so, it could be repealed in some way. And if so, would that make you massless? No. So most of the mass in the universe, at least most of the mass of the baryons in the universe, like the stuff that makes up atoms, that doesn't come from the Higgs field. That comes from the energy of the strong nuclear force. Disregarding massive objects, would anything happen if all neutrons were removed from everything? Yeah, the atomic nuclei would fly apart. Like if you take anything heavier than a hydrogen atom would just cease to exist. Why isn't neutronium natural stable via the strong force? It's actually a good question, and I've thought about it before. I don't remember the conclusion that I came to, but I guess one way to think about it is that there is a stabler configuration, which is 1 proton and 1 neutron, right? That is obviously going to be more stable because you have lower mass, so protons have lower mass than neutrons. Also, you end up with 2 different particles, and 2 different particles want to attract each other more than 2 of the same particle if they're fermions. So you have a more stable configuration in the form of deuterium. And so, and because neutrons are unstable, it just seems like it's super, super reasonable to think that if you tried to put two neutrons together, it would just promptly decay into deuterium. But I'd have to think about it some more. Maybe I'll make a video about that. Let me write it down. Why is neutronium? Do you think there could eventually be a 5th force? I suppose there could be, but we don't have evidence that it exists, right? Does measuring the state of entangled particles unentangle them? Usually it will break the entanglement, yeah. How confident are you in quantum immortality? I don't think that quantum immortality is really a thing. Is the speed of light a fundamental constant or an emergent ratio of deeper quantities? We don't know. But so in this case, it has units. It has units of meters per second or whatever. So in some sense, the number isn't really relevant. Thank you for the jewels, Zuri, and thank you for the jewels, Memori. I appreciate you. Why do the laws of physics break down at the Planck length? It's it's not that like the laws of physics break down at the Planck length, it's that our laws of physics break down at the Planck length. And that's just because we don't understand what happens there. Like the energies are just too high. We know that we're going to need to understand quantum gravity in order to understand what happens at that scale. And we just don't understand quantum gravity yet. Kung Pao Chicken sends $10. Thank you so much, Kung Pao. I appreciate you, friend. Is time travel theoretically possible when traveling at the speed of light? Is theoretical time travel backwards and forwards possible theoretically? So time travel to the future is very possible. In fact, you're doing it right now. You are traveling to the future in time. And if you travel close to the speed of light, then you'll travel to the future faster through time, or faster in time. But you can't go back in time, at least as far as we can tell. Doing so would require something like negative mass, or exotic matter, these kinds of things, which as far as we can tell don't exist. Furthermore, things with mass can't travel at the speed of light. They can only travel really close to the speed of light. But now you know. Is there a preferred reference frame hidden at the quantum level, quantum gravity level? We don't know. I kind of want to say no. At least I hope not. But that'd be it'd be very, very interesting if so. Do you think space-time is discrete or continuous? I'm pretty agnostic about it. Your opinion of how we will end rip, crunch, or whimper? I think the rip is pretty ruled out at this point. I'm pretty agnostic about whether it'll be a crunch or a whimper. It really depends on the global topology of space. If the global topology of space is like a big like three-dimensional version of the surface of the Earth, then I can see it recollapsing. But if it's like a three-dimensional version of a sheet of paper, then it probably won't recollapse. How is the universe expanding faster than the speed of light if the light is the limit? The universe isn't expanding faster than the speed of light. The universe's expansion doesn't have a speed. It's not, the universe's expansion is not like some edges are moving away at a certain speed. It's that a given chunk of matter doubles in size in a certain, or a given chunk of space doubles in size in a certain amount of time. And that doesn't have a speed because it just depends on how big the chunk of matter is, or the chunk of space is. If time dilation is symmetrical, how can you travel to the future at high speeds? So the trick is constant velocity time dilation is symmetrical. Once you start accelerating, the acceleration breaks the symmetry. So if you leave Earth at near the speed of light and then turn around, turning around involves acceleration, and that breaks the symmetry. So by the time you turn around and come back, you will have aged significantly less than the person on Earth. Kung Pao Chicken, thank you again for the $20. I appreciate it. You're welcome. This platform is amazing. You're doing a great job, and thanks for your response. Is theoretical time travel going backwards being studied or not because there's no evidence of negative mass? People think about it like occasionally. It's not something that people are working on. It's not like a field, because I mean time travel is not really a field. But like it's pretty well understood that the kinds of things that would allow for backwards time travel would basically break the laws of physics as we know them, and so we have good reason to rule it out. Like it would violate unitarity, which is like a fundamental feature of quantum mechanics, and we know quantum mechanics is really good. It would violate various energy conditions that we know hold in general relativity. So there's just good reason to rule out its possibility. Aurora, I have already answered your question. You get a 5-minute mute for spamming. Do you believe in aliens? That they've been here? No. That they exist? Yes. I really don't understand the idea of observation. How can observation change the material world? Well, it doesn't. Interaction does. Interaction changes the way that different things... interaction is when two things affect each other. And so, of course, the act of observation, which is what an interaction is, can affect things because that's what an interaction does. It's an effect. Tim for Pele asks with $5, thank you, Tim. Can you explain operator value distributions in QFT and how they differ from classical scalar vector fields? Yeah, so the thing about operators is, okay, so let's back up and think about classical. Let's just talk about scalars, for example. A scalar is just a number assigned, a scalar field anyway, is just a number assigned to every point in space, or every point in space-time perhaps. And so you can evaluate those numbers, you can take averages, you can integrate them, and that's fine. You can just evaluate things like probabilities and so on and so forth. You can even, and so they're just values that you can measure. You can measure the rate of change in a direction to calculate momentums and things like that. But what you can't do is you can't ask what happens if you reorder them, because numbers commute with each other, right? If you were to evaluate the value of the scalar here and evaluate the value of the scalar there, and then you were to evaluate them in the opposite order, you would get the same evaluation because numbers are numbers. But once you introduce operators, now you can start rearranging things and get different answers. And so by having operator valued distributions, or even just operators in general in standard quantum mechanics, not even quantum field theory, what you are able to see now is you're able to see that there is a relationship. There is an ordering relationship. There are ordering relationships that pop up. And so you can end up with observations or rather, I should say, computations that depend on the order in which you do things. And that's like a critical feature of quantum mechanics, because it means that you can have these things called observables, which are related to the operators, that don't commute with each other, that don't share overlapping bases, if you will. And that's encoded by the failure of these objects to commute. It's a good question, though. How do we know our place in our galaxy? Well, we can just map where all of the stars are, or at least where lots of the stars are, and then put it on a computer and figure out where we are. If one quark spins left and 3 right squirrels can time travel, no. What's the universe expanding into? It's not. How do you dislike emojis? How come your channel has none for members? I haven't gotten around to doing it yet. If anybody wants to volunteer to make me emojis for the YouTube channels, I'm 100% on board. I just haven't gotten around to it yet. Maybe it would encourage more people to be members if I did have emojis, but I just I just can't come up with like good emojis. So by the way, while we're on the subject, if you want access to my debate notes, which are super handy if you're debating with flat earthers or theists or whatever, if you want access to my debate notes, you can become a member on YouTube, or on you can become a member on YouTube, or you can become a patron on Patreon, and yeah, you'll get access. It's like $4 or $5 a month. Volunteer, pay people for their services, support others. Yeah, I mean, like, look, if nobody has to, if somebody has a suggestion for like an emoji, which is just like a 32 by 32 GIF or something like that, and they want it to appear on the channel, I'm happy to take those ideas under consideration. Is that for, that is for either of the channels. Both channels have the membership criteria. Both channels will have the same emojis and all of this stuff. I just haven't gotten around to doing it yet. But yeah, I mean, like, this is like, I'm not looking to like hire a designer. Like, I will do it myself eventually. But if somebody wants to do this, like, I will take their gifts or whatever, right? Personally, I don't care if the world's flat or an oblique sphere. Okay. If the speed of light is constant wherever your reference frame, how do we get red-blue shift? Well, it doesn't have, because it doesn't have to do with the speed. Redshift and blue shift have to do with how many peaks and troughs there are emitted between over distance. And so if a thing is moving away and it's emitting at a constant frequency, then the peaks will be further away from each other because it'll emit at the same amount of time, but the gap between peaks will be larger, and so you'll get a longer wavelength. What are some good books that teach me about space physics? I'm halfway through college currently. Well, if you want like an academic understanding, then just pick up a textbook. But if you're halfway, it depends on what your mathematical level is. But I literally always recommend this book, and maybe I should like put together a book list, but that would require me to read a lot of books. This is a good book. I've read this twice. It's a little bit out of date, but it's still excellent, so I'd recommend it. And it's fairly short. It's like 180 pages. Can you explain superposition and how our attention doesn't actually change it, but rather locks in? Well, so superposition is not like a strictly quantum thing. Superposition is like a thing that happens anytime you have waves. Imagine that you play two strings at the same time on a guitar. You will produce two sound waves that are in, or you'll produce a sound wave that is a superposition of two distinct sound waves. And so those will overlap with each other, and then you will hear both of them. Now, as far as quantum superposition goes, that's it's a very similar phenomenon. And when you interact with something, depending on your preferred interpretation of quantum mechanics, that interaction can perhaps cause the through a process called decoherence, the superposition to kind of pick one of them at random and then just collapse into that one. So it's not, on the other hand, if you take the many worlds interpretation seriously, when you interact with something, you enter a state of superposition, and that kind of separates, and now there's two of you, for example, where one of you measures one thing and one of you measures the other thing. But it's a matter of interaction. To start with physics, grab an introductory physics book, then electromagnetism, and then dealer's choice. Yeah, so if you actually want to learn physics at like a academic level, just pick up a university introductory textbook. That's a good way to do it. They're the standard for a reason. Does multiverse come from inflation or quantum mechanics or both? There are multiple different forms of, or multiple different multiverse ideas. One of them comes from quantum mechanics. This is the many worlds interpretation. In that case, it's not like spatially separated things. It's like there's one universe and there's just a whole bunch of different quantum layers kind of on top of each other that can't talk to each other. And so in that sense, you have a multiverse. Then there's a multiverse that comes from inflation, where you have basically an enormous empty space that's expanding extremely rapidly. And then occasionally you'll have a Big Bang popping in like vastly separated spaces, and the space between them is expanding so quickly that they can never talk to each other. And then you have spatially disconnected multiverses. Then there's the string landscape, which is a different kind of multiverse, but there are different kinds of multiverses in different settings. Theosophical Wandering sends $5 to ask, has entropy increased since the early moments of the universe? Maybe. So it's not clear what the entropy of, like, if it's not clear how we can talk about the total entropy of the universe. If the universe is infinite, then the entropy of the universe is not defined. If the universe is finite, then you can probably talk about the total entropy of the universe, so long as there's an energy conservation involved, but that's not clear either. You could talk about like microscopic statistical descriptions of the entropy perhaps, and then you might say that, yeah, the entropy has increased, especially in a finite or like a fixed co-moving volume or something like this. Or rather that the entropy current is has a positive divergence, if you will, or something like this. But yeah, so sort of depends on the context, but yeah, sort of. If you're in space and have an active continuous acceleration of, let's say, 100 meters per second squared, what's stopping you from going about the light speed? So acceleration doesn't linearly contribute to velocity at high velocities, right? You can just compute what happens to your velocity as you approach the speed of light, and it approaches it asymptotically. It's not like if you are going 1 mile an hour below the speed of light and you have an acceleration of 1 meter, or sorry, if you're going 1 meter per second below the speed of light, and you have an acceleration of 1 meter per second squared, it doesn't mean that you will reach the speed of light in 1 second. The acceleration that you have contributes less and less to your velocity as you, your proper acceleration, I should say, as you get closer to the speed of light, just because velocities don't add linearly. To prove, can anything escape out the universe? Well, probably not, especially if the universe is by definition everything. Kind of doesn't make sense to say that. So is our universe the inside of a black hole? I suspect not, and I think that you could even possibly prove this, at least in the context of general relativity. What's your take on Hawking radiation? It's probably real. Analog Hawking radiation has been produced in a laboratory, so we have good evidence, good reason to think that the formalism works. Wait, why are velocities not linear? This is a feature of living in a relativistic spacetime. Garain sends $2 to ask, could we survive if Sagittarius A star were a powerful quasar? I made a video about this recently. I think the answer is yes, actually. In fact, Andromeda's black hole is much larger than Sagittarius A stars, and an organism on a planet as far away from its black hole as we are from ours in Andromeda, the quasar would look like a bright light. It'd be like, you know, I think it'd be like as bright as the full moon or something like that. But yeah, you'd be okay. Is it true that energy is not conserved in general relativity? Yeah, generally. Globally, energy is not conserved in general relativity. Locally, of course it is, but it's kind of trivial that it is. How would you prove that we don't understand black holes past their event horizon? Well, look, so there are ways that you can understand what the dynamics are. So we're talking in general relativity. Now, maybe general relativity is wrong inside a black hole, in which case we have no reason to think that we're in a black hole at all, because we have just no idea what it would be like to be in a black hole, so we have no evidence to claim that. But if you suppose that general relativity holds inside of massive black holes, which, again, good reason to believe, because the curvatures are not so extreme once you... The larger the black hole, the less extreme the curvature is, counterintuitively. And so we have good reason to think that general relativity would hold inside an enormous black hole. And so then we do actually have a pretty good understanding of what a black hole looks like past its event horizon. Thank you for the confetti, Anthony. Why does the direction of a rotation spin a different direction when it is above or below it? It's just perspective, my guy. Does the timing between shooting each particle through the double slits matter? Nope. What's the Norwegian equivalent of a PhD? I think it's called a PhD. Can a person reach light speed? No. Is this why Gargantua from Interstellar is easier to work with? Yeah, because it's enormous. There's no way to know what the distant universe actually looks like now, right? Well, I mean, we can infer it, but yeah, we can't see it. How do we know the universe is continuing to expand and we are not viewing the Big Bang expansion? Those two things are not mutually inconclusive, or mutually incompatible, rather. Even if the universe's expansion was merely the result of inertia from the Big Bang, then we would still be seeing it continue to expand. Does the universe have borders? We have no reason to think the universe has borders, as it stands. You guys ask the weirdest questions. What do you think about cyclical universes, bangs one after the other? I think it's at least like something that can't be ruled out completely. But, you know, there are a lot of constraints on that. Can we theoretically study black holes by entangling two particles and sending one in and observing the other? No. The thing is if you're just measuring one of the particles, you can't learn anything about the entanglement structure. You can't learn anything about the other one. The only property that makes entangled particles special is that when you measure both of them, they always line up with each other. But like if you only measure one, it will look indistinguishable from just a particle that's not entangled with anything. What are the real implications of all the non-locality pop sci articles I read? Well, so if you're talking about like the non-locally real thing, the real implication is just that the universe is fundamentally quantum. That's all it means. Do events actually occur in different orders, or can we calculate the actual order of events and cancel out our reference frame? Yeah, so simultaneity of relativity is a real thing. They actually occur in different orders from different perspectives. There's no way to kind of calculate, there is no actual order for two space-like separated events. Why is gravity so much weaker than the other forces? We don't really know. It's not something that we have access to, at least not yet. Are there microscopic black holes? Not as far as we can see. Is time a constant? No. Time is a dimension in a four-dimensional pseudo-Riemannian manifold. Would going near the speed of light affect how you view the expansion rate of space? It would just look not isotropic, meaning that the expansion would look like it's moving faster in one direction than in the other direction. Do you believe that information travels faster than light in entangled particles? No, and we can prove that it doesn't. It's called the no communication theorem. It proves that you can't have information transfer between entangled particles. Is photon being massless the reason light travels at sea and we can't? I guess my question should be, are photons massless? Yes, that is the reason why light travels at sea and why we can't. Yes, photons are massless. Does quantum mean small or discrete? Always been confused because when talking about quantum mechanics, it always seems to be about small scales. Quantum, so in physics language, quantum doesn't really mean much. It's kind of just an indicator for like what kind of theory you're talking about. There are quantum kinds of theories, and then there are classical kinds of theories. And so, well, you know, you'll see the word quantum appearing just to talk about a kind of theory. Originally, quantum means like a chunk, like a small chunk of something. But that was just a name that was given to these kinds of theories, and now it's kind of more used as a label than an actual meaning. But yes, generally quantum theories are talking about things that are small because the effects, the quantum mechanical effects, kind of wash out at larger scales. When you research, does it typically start with exploring a physical scenario or from the math? It really depends on what I'm doing. So I do have some purely math projects, in which case it does just start from the math. But in other cases, like a paper that I wrote a few months back, that definitely started from a physical scenario, and then I tried to figure out a way to make the math kind of account for the things that I wanted to make it account for, and see if I could make it consistent. Someone said physics is useless. Can you give an example of what the cutting edge of physics brings practically? An example might be quantum computers being able to help with pharmacy meds and stuff. Well, I mean, you just gave an example, but like, you know, practically speaking, anytime that we are doing like nuclear fusion experiments, that's in the hopes that we will soon have a nuclear fusion reactor that is, you know, commercially viable. And that will essentially be free energy. So that's pretty useful. And plasma physics is a real thing. Nuclear physics is a real thing. Wiz Nilly sends $2. What tools do you prefer for analytical solutions? I use Maple almost exclusively. What does the expansion of space look like at the quantum level? Can it be viewed on that scale? Well, we don't really know, because again, we don't really know how gravity and space-time behave at the quantum level. But there are like guesses. I wrote a paper last year kind of thinking about how the expansion of space is like oscillatory. Or rather, I'm sorry, I should say that, yeah, the expansion rate of space is sort of oscillatory with a slight bias. So it's depending on where you're looking, it's like going like this all over the place, but it's slightly increasing. And so that's at like the ultra microscopic scale. And so on average, if you zoom out a little bit, it just looks like it's slowly growing. That's at least one possible explanation. But again, this is like a model. We don't know if that's actually true. It's just an idea that, you know, somebody had before me, and then I wrote a paper kind of working out the details of it. Where can you view my papers? You can't. I try to keep that kind of separate because I don't like stalkers, and I already have one. It seems certain that a universe with one history would outlaw backward time travel. What about the many worlds universe? So if backwards time travel is possible, then all this means is that there is a kind of like a consistency condition whenever you do backwards time travel, meaning that the backwards time travel would be part of the history. That's the only way that you could have consistency. So, but there's no free will anyway, so it doesn't matter. Thoughts on the future colliders? Is there a risk that nothing new is discovered? Yeah, that's always a risk. That's a genuine concern. Do you know what job options I have if I do my master's in astrophysics? Well, you have the option of being an astrophysicist, or rather being a grad student in astrophysics for a PhD. You have an option to work at like a planetarium, or to work at, you know, science centers, things like this. You also have options to go work in like big data science, because doing astrophysics research is a lot of big data. So there's a few options. Please don't spam questions, by the way. How do we know our math will work in very high level theoretical physics? Well, that's what mathematical physicists are for. We're there to make sure that the math works. At least that's one of the jobs. What was your favorite part of maths during university? I really, really enjoyed my abstract algebra and number theory courses because I had an excellent professor. Doesn't quantum mechanics disprove the deterministic philosophical view? Not necessarily. There are versions of quantum mechanics that are deterministic. Does the Higgs boson exist, and does it account for the effects of gravity or mass? So the Higgs boson does exist. It was discovered in 2012. And it does account for the mass of fundamental particles, but mass is just a kind of energy, and that energy was already there. So like the gravity doesn't care whether the Higgs boson is there or not. What exactly is electron spin? Well, electron spin is like a little ball that's spinning, except it's not a little ball and it's not spinning, which I know is useless. But you can think of it as just like a metaphor, kind of. Like there's nothing actually spinning, but there is angular momentum there, right? Bacon and Bush asks, sends $10 to ask, if I understand correctly, a singularity in mathematics is a problem, not a solution. How did the idea of them in black holes and before the Big Bang take hold? And is it still talked about? So singularities are generally assumed to be problems of the mathematics, yeah? And so we assume that if there's a singularity present, what that means is that there's just physics that we haven't figured out that resolves the singularity. This is what happened with classical mechanics or classical electromagnetism, for example. In classical electromagnetism, there is a singularity at the location of a point charge. The electric potential and the electric field both go to infinity. However, once we figured out quantum electrodynamics, that resolved, it kind of smeared out everything, and so we no longer have a singularity. We're kind of expecting the same thing to happen in gravity, so that there would be no genuine singularity in a black hole or in the Big Bang. Now, Utkarsh says, sir, what is with the fact that physics is basically stuck since the last 50 years? I mean, there's not been a single groundbreaking theory since the last half century. What would you say about this? Oh, well, then you just aren't familiar with what physics is, right? Like, the standard model of particle physics was like finished in the 80s, roughly, and we didn't discover the last piece of the puzzle until 2012. We also now have the entire field of quantum computing developed since starting in the 80s. It's still a super active field. People are still coming up with super new stuff. We have the entire field of nuclear fusion research, which basically kind of started in the 70s and is still active in the 70s, and we're getting better and better at it. Like, if you think that physics is stuck since the last 50 years, then you just haven't been thinking. Like, the ADS CFT correspondence was in 1995, and that was like probably the most groundbreaking thing in like the field of fundamental physics in a long time. That was only 30 years ago. So yeah, I mean, you're just a little bit confused, which is understandable. Oh, also we discovered dark energy in 96, or in 98. We discovered how the universe is slowing down. The universe's expansion, well, at least it may be slowing down now, like 2 weeks ago. So like, yeah, there's a lot. You're just not paying attention. Can we land on the sun? Can we land on the sun during winter? No, you can't. Do all physicists start out smart and get smarter, or are they normal people who get smart? I don't even know how to answer that question. Why doesn't the water get pulled to the equatorial due to the spin of the Earth, the force that keeps spinning tops up? Well, because there's also gravity pulling in all directions, but you're right. The equator, there's like a bump of water at the equator because there's more water there. That's why it's not perfect. That's one of the reasons it's not perfectly spherical. Wait, what do you mean the expansion is slowing down? Is this something expected to happen? Well, so there was a paper that came out like a week ago, or maybe 2 weeks ago or something like this, that made the very bold claim, and they have very strong statistics to back it up, that we've been misunderstanding how type 1a supernovas work. And once you account for how they actually behave, the data is consistent with the universe not accelerating in its expansion, but slowing down. And that is very surprising. Can you see the bump? No, it's very, very gradual. It's like a bulge, you can think of it that way. It's not like just a single bump. Like it's like fatter around the edges than it is around the poles. Does the recent slowing of expansion imply an homogeneous expansion distribution? No, not necessarily. How do each of the four forces interact with dark matter and dark energy? They don't. Well, okay, maybe the weak force interacts with dark matter, but as far as we can tell, nothing interacts with any of that. Well, sorry, gravity interacts with all of them. Nothing else interacts with any of them as far as we can tell. Do you do this often? I have a theory and I would like your opinion. So I don't review theories. It's a policy I have. I don't review theories that are not coming through the academic sources. Like I do peer reviews, of course, for like when journals ask me to do peer reviews, but I don't review theories as a policy. Just because I wouldn't have any time otherwise. Why does E equals mc squared have the speed of light constant in it? So E equals mc squared didn't come from nowhere. It came from an analysis of electromagnetic fields. Right. So if you have, and you know, I don't remember the exact analysis that Einstein conducted, but essentially, you can ask how hard, like if you put two charges in a box, there's going to be some electric field there. and perhaps magnetic field if the charges are moving. You could say that the box now has mass equal to the mass of the charges, but if you do that and you run the calculations really carefully, what you'll find is that pushing the box will be harder than you would expect if it was just the mass of the charges. You have to account for the energy of the electromagnetic field that the charges produce, and that affects the mass of the box. And the speed of light shows up there because light is an electromagnetic field. It's the speed of the electromagnetic wave. Sorry, the speed of light is, well, light is an electromagnetic field. It's a wave in the electromagnetic field, I should say. Can you explain strange matter? Yeah, so strange matter is like a hypothetical thing, sort of. So there's like the strange matter that we know exists, which is just any kind of particle that has a strange quark in it. And these things are unstable as far as we can tell. But there is this idea that of like strangelets or strange stars, which might be like some stable kind of strange matter where you have a baryon composed of 3 quarks, an up quark, a down quark, and a strange quark. And maybe there's some way in which those 3 things can be stable together, especially if you have a lot of them in one place. That's the idea behind strange matter. And if that's true, then if one of these things hit a chunk of regular matter, it might transmute it into more strange matter, but it's pretty speculative. What is the most mind-boggling thing in the universe, in your opinion? Black holes are probably up there. Is Hawking radiation electromagnetic? Most of it is, not all of it. What is the angular acceleration vector why does the angular acceleration vector point perpendicular to the spin of the object? So look, if you want to characterize angular velocity or angular acceleration, then with a vector, you can characterize it with a bifactor, by the way, and that's probably what you should do, but in 3 dimensions you can relate that to a vector. Then you just need a single direction that characterizes the motion. And so if you have a right-hand rule, then you can just stick your thumb in the direction, you can curl your hand in the direction of the motion, and your thumb will give you a direction. It's essentially just a convention. So if the universe is slowing down, could that imply cyclical universe? Maybe, but that is still way up in the air. Can you recommend some good literature on QFT? I haven't been able to find any really good ones. Do you mean like books? Because I think I used Weinberg when I was a grad student. I used Weinberg in my lecturer's personal notes, but yeah, if you mean books, there's like a whole slew of them. But like I'm not sure if Weinberg is really a good book, to be honest. Like it's a good book, but I don't know if it's like a good pedagogical book. Can you explain what the whole time folding in on itself means? I don't know what it means, and I don't think that the people who wrote that PopSci article know what it means either. Why do you always look confused? Well, because sometimes people ask confusing questions. Do you think our universe is in a black hole? No, I suspect not. And I think that you could even probably prove it. I think that you could probably prove it that if general relativity is true, then you can't have our universe in a black hole, or rather our universe isn't. The data is consistent with our universe. The data is not consistent with our universe being in a black hole, I should say. Are you worried about the vacuum catastrophe, or is it just a math conundrum? So are you talking about like false vacuum decay? Or are you talking about something else? What kind of physicist are you? So it says in the description somewhere, on TikTok at least, that I'm a mathematical physicist. What that means is that like I straddle the line between a mathematician and a physicist. So a lot of my time I spend doing pure mathematics research. Well, probably about half the time I spend doing pure mathematics research, depending on the time of year, of course. Right now, I have fewer physics projects than I do math projects. Earlier this year, sometime in like spring, I had more physics projects than I had math projects. And the physics that I do generally involves relativity or involves cosmology, black holes, maybe some quantum gravity, these kinds of things. Germs Rossellino sent $5 to ask, years ago, I read a book on the 10 dimensions. Is this model still relevant, or has it been debunked, replaced? What you're talking about is superstring theory. Superstring theory is still an active area of investigation. I've seen math that shows we are in the event horizon. You have not seen that. You've seen like a single, like you've divided a number by another number and then said, aha, that means that we are in the event horizon. But event horizons are not just things anytime that you have a certain amount of density. That's not what an event horizon is. An event horizon is a global space-time structure. Has philosophy of science had any significant impact on how science has done these past 50 years? I suspect not. Why are most galaxies spinning in one direction, and why is that significant? Well, look, so there was that one study by Lior Shamir who made the claim that most galaxies are spinning in one direction. I don't actually know how reliable that is. I should actually look into this and see if any new papers have come out that are in support of that or contradict it. It was a fairly small sample size, but on the other hand, you don't need a large sample size to make it come to a good conclusion. If it is the case, then it is significant because it shows that our universe is not isotropic, that there is a preferred direction in the universe, which would be very interesting, and it's another thing that we should strive to explain. Does QED exist as a mathematically consistent theory? No, it has Landau poles. So we know that it can't go up to infinitely high energy, but Landau poles are like super, super high. I think that, what energy level is it at? Okay, so the Landau poles are, well, okay, so the point is that it's known that that QED is non-perturbative, meaning that it diverges and becomes non-reliable at a certain high energy, but it's still very reliable at low energies. We know that that's true. Now, if you mean mathematically consistent, the whole of QFT is a little bit on shaky ground as far as mathematical consistency is. People are still working on that. Why don't you need a large sample size to make a good conclusion? What's the cutoff? So this is actually a good question about statistics. Generally speaking, if you're trying to figure out, like if you're trying to put things in bins, you can generally take the square root. Like this is an estimate. This is like a rule of thumb. The square root of the number of samples that you're looking at is roughly the size of your error. That's true for like a Lorentzian distribution or whatever it's called, or a Lorentz distribution. And so if you have 100 galaxies in your sample, and 70 of them are spinning one way and 30 of them are spinning the other way, well, you could say that it's probably 70 plus or minus 10 that are spinning one way. And that would still mean that, within 2 standard deviations or something like this, you have a bias towards spinning one way. And so if you had 1,000 galaxies, now it's, even if it was only 600, even if it was only 60-40, your error is now only 3%. So, or 3.3%. So the point is that like you can get pretty good statistics even with a fairly small sample size. What's the current state of string theory? Are Calabi-Yau still the most popular? Yeah, Calabi-Yau are still the most popular. The current state of string theory is not something I'm super deep in, though. I'm pretty removed from superstring theory at this point. Can you explain moon gravity lock with Earth? Is moon asymmetrical, heavier on Earth's side? No. So what happened is that, so this is called, there's a phenomenon called tidal locking. And essentially all that happens is that if you have two things that are, if you have a heavy mass in the middle and then a spinning mass that's orbiting it, the heavy mass will pull on the near side a little bit more than it'll pull on the far side. And so the mass that's orbiting it will become a little bit oblong. And if it's not spinning exactly at the rate that it takes to go around the thing, then it will be a little bit like off angle as it rotates, right? So like here's your heavy mass and like the thing goes around and it's a little bit off angle. And so because there's a bit that's closer and a bit that's further away, that can induce a torque, and it will change the speed at which the thing is spinning until it lines up with the orbital time. And so you can end up with tidal locking. Hi, is there enough scientific evidence to prove the existence of God? Well, I don't think so. Thoughts on quantum computing, feasible near future? We already have quantum computers now. It's just not clear that quantum computers will be useful, like besides for a select few number of quantum or tasks that we know quantum computers are better at. What physical principle sets the universe's global energy sign? It's not even clear if the universe has a global energy. It's not even clear if that's well defined. Do you have an example of compressing mass enough to create some sort of gravity? We can measure the gravitational pull from like a lump of lead. You don't need to compress it. You can just take a regular lump of lead. You just need really sensitive equipment. Can you explain the cosmological principle? I can't visualize the universe as homogeneity and isotropy. The idea is just that, like, the idea is that if the cosmological principle is true, then the distribution of galaxies should, if you zoom out enough, should just look like exactly what would happen if you just randomly distributed them. That's it. Can you explain why physicists are absolute theoretical and have zero touch to reality? I guess experimental physicists would take umbrage at that statement because they run experiments, hence the name experimental. What's your favorite video game? Right now I've been playing a lot of Battlefield 6. Are physical constants changing? Not as far as we can tell. Otherwise, it wouldn't be constant, right? What do you think of a torus-shaped universe? It's possible, but I think that Occam's razor kind of prevents that, or doesn't prevent it, I should say. It makes that seem less plausible. Why does time have a direction but the laws don't? That's a good question. We don't really know. Do you think the universe has a definite shape? There are things that we can talk about the topology of space. In which case, if that's a shape, then yeah, absolutely. Why is time negative when describing general relativity? Oh, that's a convention. You could make it positive and then have space be negative. Blitz, please try and actually explain singularity. Yeah, I get what it is, but how is it real? Well, we don't think that singularity, at least I don't think that singularities are real, and most physicists would agree with me on that there are no physical singularities. Is the one-way speed of light instantaneous? No, we don't have any reason to think that. Is a bubble or balloon-shaped universe definitely not it? How do we go about finding the shape of the universe? Well, it's hard because we only have access to so much universe. We only have access to a region of space that's about 100 billion light years across. And if our universe is significantly larger than that, like if it's infinite, for example, then there's just, think about it this way. The Earth is 4,000 or is 8,000 miles across, right? And yet because, we can only see a few miles because, we're fairly small things, it looks flat. And so our universe definitely looks flat in a three-dimensional way. But it could just be that it's enormous and actually is like, the 3D equivalent of the surface of the Earth. But we just can't tell, and we may never be able to tell. Did the universe begin in time? We don't know. This is a question that there's no settled science on. Is the physics in the Star Trek real versus fictional? It's fictional. Oh. Do you have a stance on the universe possibly being in a black hole if the event horizon versus observation horizon have a parallel? I think that we are not in a black hole. I don't think that there's strong evidence supporting that. How is the universe expanding? Is it physical expansion? What is it expanding into? It's expanding in a local way, not in a global way. Well, I mean, it could be expanding in a global way, but the universe doesn't have edges, right? As far as we can tell, there's no reason to think the universe has edges. So we're not talking about edges moving away from each other. We're not talking about a thing expanding in the universe. We're talking about space itself expanding. So what that means is if you have a given chunk of space that's say, 1 meter on each side, and you just let's say they just put some ping pong balls in space, delineating the 8 corners of a cube that's 1 meter on each side. If you put it in empty space and you waited long enough, you would come back and those ping pong balls would now be 2 meters across on each side, and you'd have a cube, 8 cubic meters of space rather than 1 cubic meter of space. So it's that way. It's like a given chunk of space is getting bigger. Think of another analogy that's handy is imagine that you have a spreadsheet in Excel. It doesn't have the spreadsheet doesn't have edges, right? Like it goes on forever. You can scroll forever down as much as you want. You can scroll forever to the right as much as you want. But now imagine that you just took every single cell and just made them wider. That's what the expansion would be like. Cosmic nearness. Thank you for the hat and mustache. I appreciate that. Do bounce models or cyclic universe theories still have scientific support? People are still working on them, absolutely. We are really in like the wild, wild west of cosmology right now if it's the case that the universe's expansion is slowing down, because it means that we don't have a good model of what's happening. And Brenda Lee sent the star map Polaris. Thank you, Brenda. Does holography apply even if string theory turns out to be wrong? The ideas of holography still have probably some useful meaning, even if string theory is wrong, yeah. Considering differential geometry, do you think white holes could exist? No, we don't really have any evidence to support them existing. Like, we don't have any plausible mechanism by which they could form. If they did exist, they'd be very, very easy to see, and we don't see them. So, we just don't have any evidence that they exist. What do you think about the ADS-CFT correspondence? I think it's really neat, but it probably doesn't apply to our universe. Our universe doesn't look like it's ADS. What is Lorentzian? Lorentzian is just a type of manifold, which is a mathematical object that describes spaces. Is the timescape model a better explanation of the perceived acceleration of the expansion of the universe than dark energy? No, because it seems like the acceleration of the expansion of the universe is not actually real. It seems like the expansion of the universe is actually decelerating, at least according to a recent study that I made a video about fairly recently. Asking for the fourth time, Einstein said we can't send information faster than the speed of light. Doesn't quantum entanglement contradict it? No. The no communication theorem of quantum entanglement says that no information is transferred faster than the speed of light. Explain elliptic curve cryptography. You should talk to Dr. Alvaro Robledo or Lozano Robledo about that, because he's a number theorist. I'm not. What do you think of the Milky Way being in a void? It's possible. Did the future already happen? No, if it already happened, it would be the past. Hibby Hubby sends a pumpkin pie for 850 joules. Thank you, Hibby. Oh, by the way, let me shill for myself. And just as a reminder for everybody who's watching, so there's a Discord server. If you're 18 plus, you can join the Discord server and ask questions. And sometimes I'll answer them. And then also, other people will answer them. And also, you'll get announcements about when I'm live and when I post videos, and all sorts of things like that. And also, if you want to get access to my debate notes, which I use on Monday, Thursday, Friday, and I regularly update them, then you can become a member on either of the YouTube channels. It's like $4 or $5 a month, or you can become a patron on Patreon, and you get access to the notes that I use while debating. So, you know, if you want that, that's cool. Third thing, make sure to go follow the second YouTube channel. It's called Dr. Blitz Debunks. Trying to get that channel off the ground. It'd be nice if it kind of took off a little bit more. So yeah, do those things. Anyway, shilling over, let's answer some more questions. Does atomic mass or molecular mass have a unit? Yeah, I mean, it's like kilograms. It's a certain number. One AMU is a kilogram, or it has some number of kilograms, right? Is it true that JWST can observe objects from the first 1% of cosmic history? Well, 1%, that might be pushing it, but it's pretty close to then, yeah. Pretty close. If the speed of light is constant, how can speed be relative? And can you go zero speed of light? So the speed of light, so speed is relative except the speed of light. That's roughly it. Which is, I know, dissatisfying, but can explain expansion of universe, because you confuses me. I don't know what that means. But thank you for the Indian rupees, 40 Indian rupees. So a good way to explain the expansion of the universe is merely that you have a spreadsheet and you make all of the columns wider. Now there's no edge to the spreadsheet. The spreadsheet doesn't have edges, right? But all of the regions got bigger. A small mountain sends $5 to ask, I don't know if this is a good place to ask, but I always think in fields, but can never understand why we have conserved particles. Thank you for your great work. So particle number, it just happens to be that particle number commutes with the Hamiltonian in flat spacetime. In non-flat spacetime, it commutes with the Hamiltonian and it commutes with the Lorentzian transformations. So regardless of how fast you're going, you will get the same number of particles. However, in a curved spacetime, particle number is not conserved. It's just not. This is very, very weird, but it's just not conserved. C-Bar, thank you for the $3. I appreciate you. Do you think dark matter exists ontologically? Well, yeah, insofar as like anything exists. I should say that like not total so total particle number of a certain species in a free field commutes with the Hamiltonian. Once you have interactions, particle number can change, but then you're allowing like particles to transmute into others, and there's no issue with that. Which branch of physics do you like more and why? I'm a relativist person. I like relativity, black holes, cosmology, that kind of stuff. And so, you know, I don't do much quantum field theory, but I know about it. Dixon, why don't you ever come up into my live? Are you afraid that you can't bake me? Are you afraid that you can't handle the conversation, Dixon? It seems like you can't. Also, I think that you kind of got like folded last time that you were on, what, were you on Unapologetic or on Ian's live or whatever? Like it's kind of cringe that like we live so rent-free in your head. Do you think consciousness is material? I don't know. It seems like it has some material component to it. It seems like it emerges in some sense. That seems plausible. Can we move in the speed of light with any theoretical device? Nope. No, we cannot. Wrong kind of science here, but there are genomes and markers in human DNA that don't make sense. Okay, well, ask a biologist. Have you read my super chat? I didn't see it. Did it go through? Sorry, I'm scrolling. It doesn't look like, at least on my feed, I haven't seen anything that I missed. So ask another question, and I will happily just highlight it and answer it. Sorry about that. I don't know why my thing missed it. What field of physics can one go into without too much math? Experimental physics. You don't, I mean, you still need a lot of math, but like not nearly as much as theoretical stuff. Leaky gravity, answer that question unless you meant leaking gravy. What? Sorry, I'm waiting for the question from the person whose super chat I missed. Are there physicists working on theories the public isn't ready for? I suspect not. Physicists have a really hard time shutting up about their own work. It takes a lot of self-control for me to not talk about my own work. So, wait, did I miss the question again? What was their name? I totally missed their name. One sec. Okay, so it's Naman Rames something. So I'll be on the lookout for that. Oh, no, I answered it. I answered the question. It was this guy. I definitely already answered that. Yeah. My bad. Hypothetical question. If it was discovered that we are all simulated, how would that change your or scientists' view in our current knowledge of physics? It wouldn't really change much because there's still stuff to learn about the world, the simulated world that we live in. What exactly is gravity? Mass falling into Earth, pulling other smaller masses. You can think of gravity as a phenomenon that is just like things with mass attracting other things with mass. Or things with mass attracting other things, period, actually. That's like a reasonably good description. Tim for Pele sends $5, thank you so much, to ask, is it true that particle accelerators as we use them would essentially be impossible without special relativity, time dilation, Lorentz contraction? Yeah, basically. I mean, like, we could still smash stuff together, it's just stuff would last way less time. Hippie Hubby sent another pumpkin pie, thank you. And Joe. Sent Laughing Disco for 250 joules. I appreciate that. I've been told light from the sun takes many years to get from the core to the surface, bouncing around between atoms. How does it have all frequencies if atoms can only absorb, emit quantized energies? So a single atom can only emit or absorb quantized energies. But once you have a plasma, you can kind of, like a photon can bump into a photon and kind of knock it around, because the interactions with an atom and all of the other atoms around it basically smears out the energy levels that can that can interact with the photon. And so you basically have a continuum of possible interaction energies. A small mountainside sends $10 to say, I suspect I'm wrong. So it's more asking how or why I'm wrong. When I was little, I always wondered if black holes were 4D space plus 1D time. How should I think about it? No, so black holes are regions. They are three-dimensional volumes, or I mean, you can think of them as four-dimensional space-time volumes. They're just a place in space-time, like a region in space-time, that's causally separated. Once you go in, you can't go out. That's all a black hole is. There's nothing, I mean, like, they're weird, but like that's all it is. Arnie Arningsson sent 100 Norwegian kroners to ask, what is one thing that you learned that blew your mind the most? That it would only take like half an hour to fall into, this didn't blow my mind the most, but this is up there. It would only take like half an hour to fall from the edge of a supermassive black hole to its center, which is kind of weird. Mr. J.D. Kerbo sends $5 to say the Yonsei University Type 1a supernova luminosity result was a 5.5 sigma result, right? That is wild. Is this one of those paradigm shifting moments? Possibly. Of course, it is just one paper. One paper, it often takes significantly more than just one paper to change the paradigm, but it could be the beginning of it. Did you just say we're living in a simulation? No. Somebody asked if we were living in a simulation, how would that affect things? I don't think that we are living in a simulation at all. I think that that's like completely non-scientific. I don't think that there's any evidence to support it. Assuming B theory of time, could the universe as we observe it be the overlap point of two multidimensional objects, the shapes of which determine the rate of that space expands? I don't know what you mean by the overlap. I don't know why it would be the overlap. I don't understand that really. Asking a question because I could in my physics class. We always measure the two-way speed of light. What if light in one direction goes at half of c and comes back instantly? What's your opinion? Look, it's just Occam's razor says that we shouldn't assume that that's what's happening. Also, like, it would be very, very strange. Like, what direction is the preferred one? We would expect to see other inhomogeneities or failure to be anisotropies, rather, if that were the case. Is the Pauli exclusion principle conserved when a black hole forms? We have no idea. Absolutely no idea what's going on at the center of a black hole. Zero idea. Do you think at the beginning stages of a hurricane, the military could drop a bomb in the middle of it to redirect the wind flow and stop it? I kind of suspect not. If a black hole is big enough, we could fall or live inside it for a while before spaghettification, right? Yeah, absolutely. 100% we could. Do you think gravity has a force carrier particle? Maybe. Does gravity affect quantum particles? Yes, this has been tested. Why can't a magnetic monopole exist? Well, they can exist. We just haven't found any. Why do physicists think information is conserved? This is a feature of quantum mechanics. When we talk about information, what we really mean is like the wave function is kind of like everything runs equally well forwards as it does backwards. And so you can always like reconstruct the wave function from future information. Like if you know what the wave function is now, you could reconstruct what's going on in the past. That's what they mean by conservation of information. And that's just kind of expected if quantum mechanics is true. What's one argument you could have you have that you could argue for the flat Earth? That it looks flat. That's the only one. Trouty, for the £5 thank you so much, Trouty. When an electron goes through a slit and ends up deflecting from its straight path, does it impart momentum on the slit? Electrons don't have straight paths initially, right? Like, you don't know what the momentum of the electron is initially. I mean, I guess you could if you had like a momentum beam. And then, yeah, you would, well, so it depends on what the slit's made of, how it will affect. But yeah, so this is something that's in principle available, but because the momentum is so small, you have uncertainty issues. The momentum transfer is so small that you have uncertainty issues. So that information is not available. It's not quantumly available, if you will. Unless you made unless you made like a quantumly sized double slit apparatus, that then you could probably use that to detect which thing it went through, and then it would collapse. If quantum mechanics is true, does that mean it's all theoretical still? No, it just means that, like, I'm not going to say that we've found the correct theory, that in 1,000 years we won't have a better theory. Like, you know, it could be that, you know, quantum mechanics is only a good approximation up until you get to the Planck size, and then at the Planck size we need some new theory. Under special theory of relativity and general theory of relativity, there's different views of gravity. Which do you take? So there is no gravity in special theory of relativity. It's just not part of that theory. How does quantum information define space-time geometry, but not found how it connects to expanding space when we know quantum defines space? We don't know that quantum information defines space-time geometry yet. That's not a thing that's like well known. It's not a thing that's consensus or agreed upon by everybody. So QFT is just a limit of another theory that has gravity. It could be the case, yeah. We don't know. What is quantum chromodynamics? Quantum chromodynamics is the force that allows particles like protons and neutrons to exist. It's the force holding them together. Is there a specific moment, area, or perhaps size that GR flips to the quantum? It's not a flip, it's like a gradual transition, right? Where quantum effects become more and more important. Anyone working on non-perturbative gauge theories? Yeah, lots of people are working on non-perturbative gauge theories. Yeah, absolutely. I don't know them, but like that's like a huge field. Like anybody who's doing QCD is working on non-perturbative stuff. Shadowrune sent $2 to ask, what's your favorite unified field theory interpretation? I don't think that there are any correct unified field theories. Most unified field theories have been like observationally ruled out since like the early 2000s, maybe the 2010s. They're just not really a thing. Who's your favorite physicist of the past? Einstein. Einstein's the GOAT. Most misunderstood area of physics. By lay people, it's quantum mechanics. By physicists, it's relativity, probably. Do you believe in the electric universe theory? No. No serious scientist does. What do you think about gravity leaking into the universe? It's an idea. I'm not sure how seriously it's being taken. I don't really take it very seriously. How to become a physicist? Can you give a summarized career path? Go to undergrad for physics, go to grad school for physics, get a job in physics. Do research in physics. That's it. That's the whole thing. Isn't the split experiment the most mind-blowing thing? No, it's really, the double slit, not split, slit experiment is super well understood. There's no confusion there amongst physicists. It's just for some reason, science communicators do a bad job telling people what's going on there. Now Sean sends $10 to ask, did time start at the beginning of the Big Bang? If so, would that mean the universe began to exist? What would it mean to exist without time? What would it mean to exist without time? So it's not clear if time started at the Big Bang. In fact, the mainstream view is one of inflation. And if you take inflation seriously, then there was stuff going on before the Big Bang. The Big Bang was just what happened after inflation ended. So we have no evidence that time started at the beginning of the Big Bang. No evidence whatsoever. The Big Bang doesn't speak on whether or not time began there. It's completely silent. So unfortunately, no. And James Pesh sends $5 to ask, why is G, relativity, an issue for people in the field of quantum mechanics? Oh, it's not. It's just that relativity... So quantum mechanics is... like, once you understand the math, quantum mechanics is super easy to understand what's going on. Like, the math is really straightforward. So there's just not a whole lot to be confused about. The math of general relativity is some of the worst math that exists. Quantum field theory is arguably worse, but people have a lot of experience with quantum field theory. And in some sense, people kind of set their intuitions aside when doing quantum field theory because we understand that the intuition doesn't work. But people try to still make sense of the intuition of general relativity, even though general relativity is like, why, like the math there is, it's like maximally nonlinear. And so the math is really, really hard, or our intuitions just don't map on well, to what the math is saying actually happens. And so people still try to use intuition where they shouldn't. And MILF Wrangler, great name by the way. In the diagram of the Big Bang you usually show, does the grid lines surrounding the universe represent the edge of the universe that were observed? No, so that's like a two-dimensional representation of the universe. So you can think of the surface, actually it's almost like a one-dimensional representation of the universe. So you have time running along one axis on the surface and then space running along the edge of the surface, and there's no edge to the edge. Anyway, y'all, we have been live for over an hour and a half, so I'm going to end the live here because, you know, otherwise I will lose my voice, and I have a meeting in a short while, and I have some work to do. So I'm going to end the live, but thank you guys so much for being here. Make sure that if you want access to the debate notes, that you go become a YouTube member. It's like $4 or $5 a month. It helps support me, helps keep the channel alive. And then you get access to the debate notes, and I'm going to be adding emojis at some point. I just haven't done it yet. You can also become a patron on Patreon. That's also a way that you can get access. And you should join the Discord server also if you're 18 plus, because you can ask me questions there and get announcements there. So join the Discord. It's cool. I'll see you guys all tomorrow. Same time, same place. Bye-bye.